Hello everyone. Now let's understand the different phases of compiler. So compiler will have 7 different phases. What are these phases? First, the high level language which the programmer have written is basically passed through the lexical analysis phase. So this is the first phase of compiler which basically takes the every variable or word in a program and it will considered as a lexemes. So it will take all the variables or the keywords or the particular word in a high level language program, and it will think that it is a lexeme and it converts this particular lexemes into a stream of tokens into a stream of tokens. Okay, stream of tokens means identifier. So after the lexical analysis phase, you will get the stream of tokens as a result. Now this stream of tokens will get processed by the syntax analysis phase. Syntax analysis phase is the second phase of compiler. This syntax analysis phase takes the stream of tokens and it will convert into parse tree. Parse tree. Basically, parse tree is a kind of a tree which you have to be get from a particular grammar. So this syntax analysis phase grammar grammar of a language, and it will convert the stream of tokens into parse tree. And how lexical analysis converts this lexeme into tokens? It basically uses pattern. Okay, pattern is letter followed by digit. Okay, so lexical analysis phase uses the pattern letter followed by digit star, and it converts it into a stream of tokens. This stream of tokens is converted to parse tree by the syntax analysis phase using the grammar. Okay, now when we get parse tree as a result from the syntax analysis phase, then this parse tree is taken as an input by semantic analysis phase. Semantic analysis phase converts this parse tree into a parse tree which is semantically verified. Semantically verified means it is meaningfully verified that the particular parse tree has some meanings to generate the particular language. So it is semantically verified. Semantically verified. Okay. So the difference between this parse tree and this parse tree is it is semantically verified, means it is meaningfully verified, but this parse tree is not meaningfully verified. Now after the semantic analysis phase, we got parse tree which is semantically verified. This semantically verified parse tree is now taken as an input by intermediate code generation. Okay, intermediate code generation will use various representations such as 3-address code or syntax tree or directed acyclic graph, and it will use one of the intermediate code generation representation and converts this semantically verified parse tree into, let's say, 3-address code. If it will use 3-address code, so it convert this parse tree, semantically verified parse tree, into 3-address code. Okay, this 3-address code is a popular representation of intermediate code generation, and it is not just a single representation. We have various representation, but mostly we use 3-address code representation. This 3-address code representation is taken by code optimization as an input, and it will optimize the code in a 3-address. Optimization means basically we are reducing the number of lines in a 3-address code. So it will optimize the code. After optimize the code, the target code generation is target generation code is take this optimized code as an input as an input and it will convert to a assembly language. So our target is converting high level language to assembly language. And how we can achieve this target? By using this different phases. But one thing you have noticed here is, if you count the number of phases in this particular compiler design, you got 6 phases. Then where is the 7th phase? The 7th phase is supported simultaneously by all these 6 phases, and this 7th phase is symbol table manager. Symbol table manager and error handler. Okay, so error handler and symbol table manager is our 7th phase of compiler, and this 7th phase is simultaneously supported or simultaneously provided help to these 6 phases. Okay, so all these 6 phases have to be connected to symbol table manager, and all these 6 phases will have to be connected error handler, and we call it as a 7th phase together. Okay, so lexical analysis is the first phase. It converts lexeme into stream of tokens by using pattern. Syntax analysis is the second phase. It converts the stream of tokens into parse tree by using grammar. Then semantic analysis is the third phase. It converts the parse tree to semantically verified parse tree or meaningfully verified parse tree. Then intermediate code generation takes parse tree and convert into one of its representation. Let's say 3 address code. This code optimization takes this 3 address code and it optimizes the particular code. Optimize means it reduces the number of lines in the particular 3 address code. And finally, target code generation takes optimized codes and it will convert to assembly language. Okay, and all these are supported through symbol table manager and error handler. What is symbol table manager and error handler? Symbol table manager is a data structure which stores the various information from all these phases. So suppose you have, after lexical analysis, you got some information, then you store the information in symbol table manager. Similarly, syntax analysis phase have some information, it will store into symbol table manager. So all this information provided by these different phases will contain in symbol table manager. And if you get any error after compiling the particular program, this error are handled by our error handler phase. Okay, so let's take a program of high level language and see how it will convert it through 2 different phases by using this compiler design phase. Okay, so in the next video we will take a simple program, a simple line of program, and see what are the outputs generated by the different phases of compiler. Okay.